Hello guys, welcome back to LeetCode. Today let's practice LeetCode number 606, construct string from binary tree. Given the roots of a binary tree and construct a string consisting of parentheses and integers from a binary tree with the preorder traversal way and return it. The preorder traversal is like we visit the node or the parent, and then we visit the left child and the right child. So like this example, we are given the root, so we visit the root 1 first, and then we go to the left children, so that is 2. And then we go to the left children, so that is 4. Since 4 has no left children, so we don't print it here, and it also has no right children, and then so we'll go back to 2 and then visit 2's right children, but there is no right children of 2, so we go back to 1 and then let's we'll visit the right children of 1, so that is 3. So this is the preorder traversal way of the tree. And now we want to have a string that consists of parentheses and integers. So that means for this layer, we have 1. And we want to put his left and right subtree as a separate parentheses. So here we want to put the left tree, and here we want to put the right subtree. And for the left subtree, for these 2, we'll have a 2. And then we also want to put the left subtree of the 2 in a parenthesis and the right subtree in another parenthesis. And then we'll go to the next layer. So for the 2, his left subtree, we have 4. And we also want to put the parenthesis here. Okay. And for the right subtree, it doesn't have any right subtree, so we will leave it as a empty parenthesis. And for the right children of 1's subtree, we'll want to put 3 here, and also we want to put the left subtree and the right subtree of 3, but that is empty, so we put 2 empty parentheses here. That is how we construct the parentheses, or that is how we organize the parentheses. But here it says you want to omit all the empty parentheses. So that means we want to eliminate this and this and this and this. But he also says that we do not want to affect the one-on-one, the one-to-one mapping, the mapping relationship. So what does that mean? Okay, it means from this a single string, you can only construct to only one tree. So there shouldn't be any ambiguity of what kind of tree this string can construct. Like if we have the string something like we have a 1, the 4 is the left subtree of the 2, and that is correct. But how about if now the 4 is the right subtree of 2, and actually here should have 1 parenthesis here? So here comes to some ambiguity. So if there is a condition where we don't have any children as the left subtree, but we do have a children of the right subtree, in that way we cannot omit this parenthesis. We have to put the parenthesis here because it means that there is a empty left subtree, and the element after the empty left subtree is the right subtree. I want to use the stack data structure to solve this problem because the stack is a good way to traverse the tree. Maybe the stack is somehow like we have to write more code if we use stack instead of recursion. But I think we can use stack to solve this problem because this is a good practice. Now let's go back to the stack traversal. The traversal using stack. So let's have a review. Suppose now we have a 5 node that attach to 3, not 3. And how do we traverse the tree using stack? Okay, so let's see. Because the stack is a last in first out data structure, so we have to keep in mind of what is the order of the elements that we want to put in the stack. So first, let's put 1 here. And then, okay, so now I just want to go through how to use the stack to traverse the tree. So now we can just ignore the parenthesis thing now. So we have 1, and then we have 2 children, 2 and 3, because the stack is last in first out. So we have to put 3 here because we want to process 3 after we process 2. So we have to put the 3 in the stack first. It will let the 3 to process it later. Okay, so we have 3 and 2. Okay, so one thing I forget is that so here I have a 1, right? And since the 1, let's pretend, okay, go back. So let's have a 1 here. So since the 1 is the first element or the top element of the stack, so we can pop out the 1 from the stack and then process it here and then put 1's children onto the stack. So we put 3 and 2. And then for the 2, we process it so we can pop it out from the stack and process it. And also we want to put the children of 2, so that is 4. And then for the next iteration, the 4 is the top element in the stack, so we pop it out and then check if if 4 has children. No, it doesn't. So we don't put anything on the stack. Then we go back to check the stack. Okay, so now the 3 is the top element of the stack. So we pop the 3 out and process it and then put his children onto the stack. So we have 5. And then the 5 is the top element. So we process it and pop it out from the stack. And there is no children of 5. And also, now the stack is empty. So we have finished the iteration or the traversal of the tree. That is the general mechanism to traverse the tree. And now we have to think about how to add the parentheses into our solution. So for the solution, I will use 2 variables to keep track of 2 stats. So the first stat is the string, the return string, or this one, the output string. And the second variable I want to use is called visited. So it means whether or not a node has been processed before. I will talk about it later. So first, we have the root node in our stack. So we have 1 here. And let's start the iteration or the while loop. So first, since the 1 is our the top element in the stack, let's check if it already be visited. Is it in here? No, it's not in this set. So first, let's see, mark it as visited. And since we are going to have a new node, so we want to put the open parenthesis and 1, the value of the node, into the output list, onto the output string. Okay, and the next, we want to add 1's children onto the stack. So we want to put 3 and 2. Okay, and the next step is to, it is not to pop out the element 1 from the stack, because we have to use the 1 later. Okay, so that is what the difference between from the traditional traversal way. Okay, and then now let's check the 2 is the top element of the stack. So let's check, is 2 being visited? No, it is not. So let's first check put 2 being visited, and we have to append an open parenthesis and 2 onto the output string. It means we encountered a new node. And then we want to put 4's children onto the stack. So we have 4 here. Okay, now here is something we have to be careful. So now we have only the left children, we don't have the right children. So in this case is intuitively just put the left children onto the stack. And if there are some other conditions, we have to check. Okay, and I will explain it later. So now let's put 4 onto the stack. Again, we have to check. Now the 4 is on the top of the stack, and let's check 4 is not being visited. So we first mark it as visited, and we want to put an open parenthesis and 4. And we want to put 4's children onto the stack, but there is no children, so we don't put that on the stack. Okay, and then finish this iteration, and then goes to the next iteration. We found out, okay, 4 is still on the top of the stack, but this time it is being visited here. So since it is being visited, it means that we are going to leave this node, because we already processed this node and we already put his children on the stack. So we can leave this node. So in order to mark the end of this node, we have to put a close parenthesis here. And also this time we have to pop out the 4 from the stack because it is already been visited. And now let's check the 2 now is on the top of the stack, and 2 is also being visited before here. Since it is already been visited, so we also want to have a close parenthesis to mark that we are going to leave this node. And also we want to pop out 2 from the stack, and it goes to 3. So now the 3 is on the top of the stack. Okay, so let's check. Since 3 is not in the visited, so it is not been visited before. So first we have to mark it as a visited because we want to visit it now. And for a new node, we have to put the open parenthesis and the value itself. And also we want to put his children onto the stack. Okay, here comes to the interesting part. So for the 3, it doesn't have the like left children that is a null, but it has a right children. So in this case, whenever a node it has no left children but does have the right children, it means that we have to put an empty parenthesis and then the right children's value. Now we have to put an empty parenthesis here. Then we'll put the right value, but we'll put it after we visit the vibe. We want to put 3 children onto the stack. So it has a right children that is 5. Put 5 on the stack. For the next iteration, now the top element is 5. So first we put 5 on the visited set. And because we encounter a new node, we want to put an open parenthesis and the 5 here. And for the next iteration, the 5 is still on the top of the stack. So now we have to check if 5 is already being visited before. Yes, it is. It is in this set, in the visited set. So it means we already processed the 5 before, so we want to leave this node, so we'll give it close parenthesis and also pop 5 from the stack. And for the next iteration, it goes to 3, but let's check the 3 is also being visited, so we can pop it out from the stack and also put a close parenthesis here. And for the next iteration, there is only 1 here, and 1 is being visited before, so we pop out the 1 from the stack and we put the close parenthesis here. Okay, now here is our solution. But you can see that here is some parts in the answer, like in this answer, we don't have the parenthesis in the output, in the outmost, that contains all the string. So we have to remove this parenthesis and also this parenthesis. And that is easy. We can just use the string index manipulations to get rid of the first and the last element of the string. Okay, so now let's talk about the time complexity. So we will put the element in the stack and push out the element out of the stack once. So for the time complexity is linear. And for the space complexity, because we have to construct the stack when we are traversing the tree, so the space complexity is also a linear time. That is n. Okay, now let's start coding. Okay, so first we want to have a stack, and we put the root in our stack, and also want to have a visited set and the results. Here I want to have a list, and then in the end I will join the element, every element in the list, and then output a string. So we don't have to update the string multiple times, which will like to have copy the value from the original string to the new string, and that will like to it's not an efficient way. So like this one have a list is a better. And so we'll want to iterate the stack until there is no element left in the stack. So first we want to check whether let's call it element. So first, let's check if the top of the stack is already being visited or not. Okay, let's check. If it is already being visited, so we want to append the clothing parenthesis into the string and want to pop out the element, the stack, and then finish this iteration. Okay, and if the element is not being visited, first we want to we'll put the element onto this visited set, mark it as visited. And then append the open parenthesis, because now we encountered a new node. So besides the open parenthesis, we also have to put the value of the node. So what is the value? So we want to turn this integer into string, and so it is in here, .val, elements.value, and turn it into string. Okay. So after we process it, and then we will put its children onto the stack. So first, let's check. We want to put the process the right children first, because in the later term we want to retrieve the right children after we process the left children. So we only put the element on the stack if there is a node. Okay, so we want to check if the element that writes is not none. And then we will for the left children, there are two circumstances. First, there is no element there is no left children, but there does have the right children. In this way, we will put the empty parenthesis onto our string. So we don't have left children, but we do have the right children. So we want to append the empty parentheses. Okay. The next thing is, now if we do have the left element, so we'll put the left element onto the stack. Okay. And in the end, we will join the string, the list. But without, we don't want to have the almost parenthesis, so we'll just get the string from the first index and onto the last index, but not include that. Okay, and now let's run the code. Okay, pass. Okay, good. Okay, thanks for watching. If you like my video, please like my video and subscribe to my channel. Thank you. See you next time.